Hi everybody, so we've been looking a lot at these things, these bumpy ridges along the leading edge of a fin, and of course this came from whales. We've been using it in air, but air and water are understood to be fluids. The difference between air and water is that water is a liquid, and that means that it will fill a volume that is equal to its own volume. Air as a gas will basically fill any volume you put it in, but they're both fluids and both behave the same way, and we know these were derived from whale fins, so we should be able to use these to extract energy from water. Now traditionally there's basically two ways of doing that, and the first way was just to use the dead weight of water to push a wheel, and that's exactly what a wheel was. But of course that has its limitations. They're not very efficient, and turbines developed. Turbines use a different method. The perhaps most successful and efficient turbine is the Pelton wheel that came along in the 1870s, and it uses a jet of water aimed at some buckets, and it's what's called an impulse turbine. It can use the kinetic energy of the water and extract that energy as rotation. Later, of course, we've got things called reaction turbines that are able to extract both the kinetic energy and the pressure energy from it. But given this came from a whale, we should be able to turn it into a turbine blade, point a jet of water at it, get it to rotate and extract some energy out of it, or at least that's the idea. So in order to explore that idea, what I've done is create this turbine blade. It's just a smaller version of this. So I've taken this and chopped it off there, shrunk it down a bit, and stuck it onto a PC fan. PC fans are great things for testing because they're really easy to turn into generators. All you actually do is snap off the blades, take out the electronics, and solder a couple of wires to the coils you'll find inside. There are quite a few guide videos on how exactly to do that, and I've done one myself, so if you're interested and don't know how to do that, just leave a message in the comments and I'll link to those videos explaining how to do that. But it's really easy to do. So what I've done is I've taken this, and there's a little indentation on the reverse side that exactly fits on there. That's an 80mm PC fan, incidentally. And I've glued that on and glued it to this backing. It's just a bit of backing board to hold everything stable. And what we're going to do is take this, point a jet of water, and see what happens. Okay, we brought it outside. Let's turn the garden hose on it and see what happens. I mean, partly we know what's going to happen. I'm going to get wet. Okay, that was cold. Now, it definitely worked as a turbine. I couldn't tell you which kind of turbine it was, whether it was impulse or reaction. But apparently, when the water hits that blade at the point of the tubercle, the flow is separated, and that's part of why the drag decreases and the lift increases. Now, these are beginning to creep in everywhere. You're seeing them in wind turbines at the moment. They've been starting to be put onto wind turbines and supplied as a kit for you to modify your own wind turbine. And you find them in slightly more bizarre places. They're on the kegs of surfboards, that kind of thing. But I've yet to see anybody looking at these in terms of water power generation. Now, we use a water jet, but I would think with something like the Wave Dragon, for instance, it might be an interesting way to look at something like that. Now, I've put this on Thingiverse. I'm not sure if anybody's interested in it or not, but at least it's there for you to play with if you are. And it's just this section here that you'll have to modify if you put a different motor. And as I said earlier, you could put the motor out so the motor doesn't get hit by the water. Anyway, I hope you enjoyed the video. Thank you very much for watching, and please do remember to like and subscribe.